Hi there. I hope everyone is staying safe and healthy in their own bubbles, in their own homes, in their own locations. So, this lecture presentation is a continuation of the introductory lesson for the course Integrative Programming and Technologies 1 being offered by the Department of Information Technology of the Central Luzon State University. This presentation is still focused on concepts related to scripting. So we start by looking at John Ousterhout's dichotomy. John Ousterhout's dichotomy states that high-level programming languages tend to fall into either scripting languages or system programming languages. This is also synonymous to programming in the small, which can be mapped to the use of scripting languages versus programming in the large, which is mapped to applications or systems programming. We have an understanding that programs written using applications languages, or what we call system programming languages, are typed statically. They also support creating complex data structures. They are compiled into machine code and they are standalone. That means they operate largely independently of other programs. Whereas for scripting languages, these languages are typed dynamically. There is little or no provision for complex data structures, and codes or programs written using scripting languages are mostly interpreted. By the way, John Ousterhout is the man behind the TCL language. So, system programming languages tend to be used for applications with heavy or complex internal functionality, those that employ complex algorithms and data structures, those that require high performance, for example, operating systems, database servers, and web browsers. John Ousterhout claims, still we're discussing about this dichotomy, that scripts tend to be short and are often written by less sophisticated programmers. So in scripting, simplicity and ease of interaction with other programs is more important than efficiency. So common applications for scripting are web page management, web page generation, report management, uh, graphical user interfaces, or even in implementing some tasks or actions for system administration. We define scripting as coding for a special runtime environment to automate the execution of tasks, and scripts are often interpreted rather than compiled. When we say runtime environments, these are the host programs and could refer to software applications, web pages within a web browser, shells of operating systems, embedded systems, and games. Hence, a scripting language is viewed as a domain-specific language for a particular environment. In the case of extending applications via scripts, the language used is also known as an extension language. Sometimes, scripting languages are considered as very high-level programming languages, as they operate at a high level of abstraction. Moreover, some scripting languages are referred to as control languages, particularly for job control languages on mainframes. Scripting languages can loosely refer to dynamic, high-level, general-purpose, interpreted languages. So we look at these combined characteristics. A dynamic language typically refers to a language that executes at runtime programming behaviors commonly performed during compilation by static programming languages. Then a high-level language uses coding elements with higher level of abstraction, or it may use natural language elements. So here, the amount of abstraction provided defines how high level a programming language is. Then, being general purpose, a general purpose language is designed to be used in the widest variety of application domains, and not only within a specific application domain. Then we have being an interpreted language. We have been repeating this time after time in our discussion. An interpreted language executes instructions directly and freely without previously compiling a program into what we call machine language instructions. So the term script commonly refers to small programs, probably up to few thousand lines of code in such a high-level general purpose interpreted languages. So some of these languages were developed for use within a particular environment, but have evolved into portable, domain-specific, or even general-purpose languages. Moreover, some general-purpose languages have dialects that are already used for scripting. This slide shows that scripting languages covers a very broad spectrum. At the narrower end of the spectrum are domain-specific scripting languages, and at the broader end are the general-purpose scripting languages. Some languages such as Perl, Python, and Ruby are intended for general-purpose use, as they support features such as modules, separate compilation, reflection, and other features being offered by similar general-purpose programming languages. However, still, there are lots of scripting languages that are only intended for use within a defined domain. So here are some examples of scripting languages. We have Bash. It's a shell scripting for Unix operating systems. ECMAScript and JavaScript. These are almost related scripting languages. ECMAScript is actually a standardized JavaScript language. So they are primarily scripting languages for web browsers, but also considered general purpose. The Visual Basic for applications. This is a dialect of Visual Basic for MS Office applications. The Emacs Lisp, a dialect of Lisp. This is a programming language. Lisp is a programming language formerly known as LISP. LISP is the second oldest high-level programming in wide use today. So we know that Fortran is the oldest. Lua is an example of a scripting language used for extension. Then we have Python. Python is a general purpose language commonly used as an extension language. And for game systems, we have the Linden scripting language and Trains. So these are scripting extensions for gaming systems. So it is claimed that almost all of the most interesting features and powerful features of scripting appear in Python. For example, having these true iterators, array slices, multi-way assignment, the use of anonymous first-class functions, and functional type list. Scripting languages are intended to be learned quickly, and they are written as short source code files. They have simple syntax and semantics, hence they are called script. Scripts are executed from start to finish, and there is no explicit entry point. In programming or in computing, entry point is where first instructions of a program are executed. So for instance, in C programming or in Java programming, you have to start the execution of a program in the main functions. So scripting languages are interpreted. Most are interpreted rather than compiled, although host environments are usually compiled. Scripting languages use high level of abstraction. In this way, we spare users the coding details of internal variables, data storage, and memory management. Scripts can just be created or modified by users or developers. We call this end user development. However, there are scripts that are large in size. So for instance, for large portions or extensions of game software, such large scripts are often just distributed. We look at a short history of scripting. Scripting was used in early mainframe computers in the 1950s. For example, JCL, the job control language that were used to control batch processing of early IBM mainframes. Then we have the interactive shells that came in the 1960s with the first time sharing systems. So these systems used shell scripts to control the execution of a program within another program. That is what we call the operating system shell. So a shell typically is a user interface to access an operating system's services, either through command line interface or using graphical user interface. Then came the general purpose scripting languages, such as TCL and Lua. General purpose scripting languages are intended to be embedded in any application. For instance, TCL. That name originally comes from Tool Command Language. Later, there are softwares that incorporate scripting languages. For example, the modern web browsers that provide a language for writing extensions and controlling the browser, like JavaScript and XUL. XUL actually stands for XML Unified Language. This was developed by Mozilla and it is implemented as a dialect of XML. Most scripting languages have had only a single person driving the initial development. However, due to the dynamism of the open source community and the freedom from working within an ISO published standard, scripting languages have been at the recent forefront of programming language development. So we look at some types of scripting languages or classifications of scripting languages based on their purpose. Although it is observed that there is a considerable overlap among the types. So we have shell languages or job control languages. A large number of scripting languages originated from job control automation in the time of mainframes. So shell languages start and control the behavior of system programs. So as an example, in the early 1970s, a command language for automating the control of Unix programs was written, and this was called as shell or SH. This was extended to allow for variables and control flow and was later known as bash, BASH. This is the default Unix command shell. So shell languages allow for many operations including manipulating file names, arguments, and commands, and for tying programs together. Then we have the editor or text processing languages. These are useful for interactive text processing features such as insertion, deletion, replacement, bracket matching, and other text processing features. Typical examples of text processing scripting languages are SED, SED, and awk, AWK. SED, which stands for Stream Editor, is a very powerful and can be used to write complex scripts, but is more commonly used for one-line programs. So some wanted to modify and improve SED. So here comes AWK or awk. This is an attempt to modify SED to look more like a programming language. Then we have glue languages. Glue languages are scripts that are used to connect software components. They adapt different components of code that would otherwise be incompatible. Usually they are general purpose scripting languages and inherit a rich set of features from both shell languages and text processing languages. Other types of scripting languages, we have GUI scripting languages. These languages interact with GUI components like a human user would, and they are used to automate user actions. Then we have the application-specific scripting languages, a domain-specific scripting language or specialized for a single application. Then the extension embeddable languages. So instead of an application-specific script, there are general purpose scripting languages embeddable in application programs. So we have an example like JavaScript that began and still a scripting language inside web browsers, but its standardization as ECMAScript made it a general purpose embeddable language. So ECMAScript was standardized by ECMA International according to the document ECMA 262. So this slide shows various examples of scripting languages. There are thousands. There are thousands and thousands of scripting languages being used today. We see there AppleScript, so it's a special domain-specific scripting language for Apple applications. And this is the continuation of our list. So that's the end of this lecture. If you have questions, don't hesitate to flick me an email, guys.